We are group S-12 and our topic is direct memory access. So in this presentation, we are going to see the following topics, that is introduction, what is DMA, the applications of it, different modes of DMA transfers, DMA signals, advantages, disadvantage, and lastly the conclusion. So introduction. In many input and output interfaces, it is necessary to transfer data from an interface at a higher rate than simple program I/O loops. The CPU cannot perform other operations during the program controlled I/O programs. That's why direct memory access is important.
So what is DMA? DMA stands for Direct Memory Access, and it is a method of data transfer from input-output devices and the direct main memory, bypassing the CPU, hence to increase the speed of data transfer. Without DMA, the CPU is first only engaged with the I/O devices for data transfer and is unable to do other operations and hence reduce the processing speed. With DMA, the CPU initiates the data transfer and does other operations. After the data transfer is complete, the DMA controller can set an interrupt to the CPU that the data transfer is complete. So this feature is very useful if the rate of data transfer is very high and the CPU cannot keep up with it, or the I/O devices have a very slow data transfer speed. Applications. So the DMA read transfers data from the memory to the I/O devices. It also write transfers data from the memory to the I/O devices. So the DMA saves processing time and is a more efficient way of data transfer from the computer memory to the devices. In PC, data storage, communication, and graphics need a very high data transfer rate, and hence DMA is also used there. There are two modes of DMA data transfer. First is burst mode, in which the whole block of data is shared in one continuous sequence. This method is beneficial for loading programs or data records into the memory. And the second method is cycle steering mode, in which the DMA controller uses one system bus for transfer of one word and returns it to the CPU. This method reduces max I/O transfer rate and also reduces interfaces of DMA controller in the memory access.
So as we know, there are two control signals used to request and acknowledge a direct memory access. The hold signals as an input is used to request a DMA action. The HLDA signal as an output that acknowledges the DMA action. When the processor recognizes the hold, it stops its execution and enters hold cycle. HLDA becomes active to indicate that processor has placed its buses at impedance state. So here are the advantages and disadvantages. Advantages. First, DMA enables more efficient use of interrupts. Second, high transfer rates. Third, increased data throughput. Fourth, DMA supports faster CPUs. Fifth, DMA devices can communicate directly with memory. Disadvantages. DMA hardware is complicated. Second, memory problems between CPU and DMA. Third, DMA transfer require a DMA controller to carry out the operation. This is the conclusion of our PPT. DMA is essential to high performance embedded systems and also playing an essential feature of all modern computers, as it allows devices to transfer data without giving overload to a CPU. Second, DMA is feature of computer hardware that allows devices to gain access to the main bus linking the processor to the system memory and move data directly between main memory and other